Welcome to this video on AutoSys SAP DI solution. This video will explain the SAP data intelligence integration with AutoSys and its benefits to the AutoSys user community. We'll provide technical insights to identify the integration components and understand the deployment sequence. We'll focus on the design and execution sequence of scheduling graphs job in SAP DI. Finally, we'll run through a demo. SAP Data Intelligence, DI, is a powerful solution for transforming scattered data into valuable insights. It helps businesses connect, manage, and process data as part of SAP's business technology platform. Known for being reliable, it offers a full solution for managing data efficiently. SAP DI integration enables you to easily manage, execute, and monitor SAP DI jobs in your SAP Data Intelligence environment, simplifying job orchestration and execution. AutoSys plays a central role in orchestrating operations across multiple environments, including the cloud, and synchronizing these processes with other non-cloud operations. Integrating SAP DI allows us to centrally configure process automation in AutoSys. Subsequently, we can start, schedule, monitor, and supervise all processes from a single interface. These SAP DI processes seamlessly sync with different environments supported by AutoSys, such as applications and databases. This integration allows you to effortlessly execute and monitor SAP DI jobs through AutoSys. By leveraging AutoSys' advanced capabilities, you can accelerate your digital transformation efforts with greater success. Simply define your SAP DI and let AutoSys manage the scheduling of these workflows seamlessly. AutoSys lets us build configurations with intuitive interfaces and monitor them through simple dashboard tools specifically designed for operational use. Statuses are clearly indicated, and accessing logs is as simple as clicking a button. From an operations perspective, AutoSys greatly simplifies the configuration and orchestration of SAP DI jobs. Externalizing operations to a tool with a high degree of third-party integration means we can synchronize all cloud with non-cloud workloads. Using various agents and job object types, we can build sophisticated configurations involving multiple applications, database packages, system processes like backups and data consolidation, file transfers, web services, and other on-premise workloads. The job submission sequence is relatively simple because all job definition properties are stored in the AutoSys plain old Java, or POJO job. All the target system properties, including the endpoint, username, password, and other parameters, are defined in the J2EE parameters. These parameters may vary depending on the authentication method used. Let's look at the sequence of execution. We start with the three main components: the AutoSys scheduler, the system agent, and the SAP DI server. The AutoSys scheduler submits the POJO job to the system agent. The system agent acknowledges the job from the scheduler and initiates communication with the SAP DI server. Authentication is then initiated, with the system agent posting basic authentication depending on the specifications provided in the authentication J2EE properties. In this video, we are using basic authentication using a proxy, which uses a combination of a username and a password. AutoSys allows connections via proxy, providing additional flexibility and security in accessing SAP DI resources. Once authenticated, the agent submits the job to the SAP DI server as a post request. The SAP DI server identifies the matching job and executes it. The job execution returns a JSON response which contains the execution details. The SAP DI server and system agent then monitor the job until it reaches its final state. Once the final state is obtained from SAP DI, the job status in AutoSys is updated accordingly as either canceled, succeeded, or failed. Let's look at how to deploy the integration. First, ensure the Application Services plugin is installed as a prerequisite. The Application Services plugin and Pojo extension have the CFG extension. In older agent versions, you might encounter a PAK file instead. Next, download the plugin extension package from the marketplace. This package contains all the necessary elements. Unzip the package and extract the content into a temporary folder. Navigate to System Agent Install Directory. Next, we must stop the system agent with the cyb agent-s command. Install the plugin extension with the command plugin installer path to CFG file. Now, restart the system agent with the cyb agent-a command. Remember, this integration uses SAP DI Public REST API. We will start or trigger a SAP DI Pojo job in our demo. First, let's establish communication with the SAP DI server. After communication is established, we can execute and supervise the job. Let's log in to AutoSys. Click the Quick View tab to view the job definition. Select the job to open the job definition. The job employs basic authentication using a proxy for the demo. Click the Quick Edit button to view the required parameter. The first step in executing a job is to select the machine on which the job is to be executed. The first parameter is the class name SAPDI, and the second is the method name StartGraphJob. Now, at the gateway parameters. Understanding these gateway parameters is an essential part of the process. The endpoint parameter indicates where the SAP DI service resides. The username is required to authenticate with the server, and the password associated with the username is also used for authentication. The tenant parameter specifies the instance or environment where the job will run in SAP DI, ensuring it executes in the appropriate context. The payload parameter specifies any additional JSON data that should be included with the request. If there is no additional data, this parameter can be left blank. The dump trace log parameter enables the generation and retrieval of trace logs for detailed monitoring and troubleshooting of jobs and processes in the SAP Data Intelligence environment. Then we have proxy parameters. The proxy hostname specifies the hostname or IP address of the proxy server to which the connection is established. The proxy port indicates the port number the proxy server uses for communication. The proxy username is required for authentication with the proxy server. The proxy password is the password associated with the username for authenticating with the proxy server. The max retry parameter is crucial as it determines the maximum number of attempts the job status will be fetched from the SAP DI server for monitoring purposes. The sleep interval parameter specifies the duration of time the system agent should wait before querying the SAP DI API again to obtain the job status. In the event of a brief downtime experienced by the SAP DI service, the failure interval parameter comes into play. This parameter specifies the amount of time in seconds before failing the job due to API failure. Lastly, the log level parameter allows you to specify the level of detail that should be included in the log file. Once you have specified all the J2EE and other parameters, click Commit and close it. That completes the job definition. Let's now start the job. Once all the parameters are defined, select Start the Job and click Go. To confirm the job execution, click Yes when prompted. Notice that the current run number for the job is 1125. Upon refreshing, a new execution is triggered, increasing the run number from 1125 to 1127. A status of success indicates that the last execution was completed successfully. To access the spool files, simply scroll down on the user interface until you locate the spool files section. From there, select the desired file and click on the Go button. You will then be prompted to specify the number of lines you wish to display. Reports for all statuses are accessible for further investigation or utilization. As we examine the successful job, we can see that all parameters passed by the user, such as job details and authentication parameters, are displayed. Now, take a quick look at the job status in the SAP DI instance. In our example, the counter has successfully reached its final state after multiple executions. To view the latest log, simply navigate to the Trace tab from the available list of tabs. Click the Download button to retrieve all instance execution details and display the number of processed rules. For more detailed graph-specific information, switch over to the Metrics tab. Here, you can find data pulled, successfully processed rules, and any failed or encountered errors. This data is also included in our response. Now, let's switch to AutoSys to review the reports. On the right-hand side, you'll find the graph prepared and executed as per the customer's request. We store both the trace log and metrics for this graph. Customers may also be interested in other graphs where metrics are populated. We track each graph start and stop times, focusing on job execution. The job initiates in the pending state, where the system allocates necessary resources. It then transitions to the sponsorship state, confirming that all dependencies are satisfied and execution can proceed. Upon entering the running state, the system activates two monitoring processes. Tracelog URL generation. A URL for the tracelog is generated, offering a real-time link to track job activities and logs. This URL remains active throughout the job's execution. Tracelog dump. Simultaneously, the system begins a tracelog dump, capturing detailed records of job activity. This log is essential for troubleshooting and diagnosing potential issues. After completing all assigned tasks, the job transitions to the completion state, marking the end of its execution. Let's revisit the SAP DI instance and explore examples of graphs and operators highlighting its capabilities. SAP DI seamlessly integrates with Kafka, making it easy to load data into SAP HANA and retrieve it without disruptions. Furthermore, SAP DI now supports Reclient and introduces a new set of operators to improve its functionality. With SAP DI, you can effortlessly transfer data between HANA databases and from Kafka to HANA. In addition, SAP DI now integrates with Amazon S3, streamlining the process by allowing you to define credentials without the need for coding. It automates data retrieval from your S3 bucket and loads it into SAP, emphasizing smooth connectivity while reducing the need for extensive setup. That wraps up the demo on how AutoSys can integrate with SAP DI to execute and monitor various jobs. Thank you for watching this video.